Okay, Algebra Kids, we're going to start Chapter 7 review today, and then we'll probably finish it on Monday. But I've put together, we are not doing the last section of the chapter. So I don't know if you can see over here off to the side, 7-1. This is all the questions from 7-1, 7-2. We'll try to get through at least those. I'm hoping to get through the story problems also today. And then maybe we'll save 7-3, 7-4 for Monday. So let's at least try to get through that part. But I'm going to do like one or two from each section with you. And then I'll have you do the other ones with the time that you have in class for homework, okay? So 1 through 5 is saying, it's asking a couple different questions. It says, determine whether it's an exponential function or not. Not all of these functions are exponential. So first say like, yes, it's exponential, or no, it's not exponential. If it is exponential, tell whether it's growing or decaying. So like, is it doing one of these for its exponential function, or is it going downhill and kind of tapering off? So let's just, I'm going to pick on like number 1, and let's pick on like number 3. I don't know. Number 1, the important thing about an exponential function is that your exponent has to be your variable. Okay, so some base number, we call this my base, my exponent has to be the variable that I'm dealing with, okay? And because my base, so this is an exponential function. This is, yes, he's an exponential function. Now, the base is what I am taking the x to. So like if I were to plug numbers in for x, what I'm doing is I'm multiplying by 0.9 every time, okay? So imagine that like you're taking something and you're multiplying by 0.9. and taking that number and multiplying it by 0.9 and multiplying by 0.9. Because this number is less than 1, it is making him go down just slightly every time. So this is going to be a decay function. An example of when that would occur, let's talk about growth versus decay. A function is going to grow, for example, in like money in a bank or interest. When you're finding interest. Money is also, or things are going to grow when you have to deal with like population. A lot of times a population will grow exponentially. Bacteria will a lot of times grow exponentially. Okay. Decay functions will be like a car that is getting driven off the lot, like it goes down in value, it decreases in value. You might have like radiation is also another one that will decay exponentially. So like the amount of radiation that's, when a radioactive bomb goes off, the amount of radiation that's in the atmosphere will go down exponentially every time. So those are just some examples of growth versus decay, okay? So this is 0.9. That means it's going down a little bit every time. So that might be an example of a radiation or a car or, losing value, that type of thing. So yes, it's an exponential function. It's a decay. All right. Number 3, yes or no, exponential, not exponential. I told you the exponent has to be the variable, and my exponent here is 5. So not an exponential function, because this is actually a polynomial function. He is a quintic function, okay? He's going to look like, I don't know, like one of these or something. Actually, he's going to be negative because he's going to go in. Negative means he's going down, so he's going to like do one of those, something like that. So not exponential. Okay, so answer that for 1 through 5. There is that. Let's go on to, I'm going to do number 7 with you just because he has a fraction. So the deal here is this is the tricky part. This is going to be an exponential function for 1 because the exponent is x, but they're asking for graphing the function, state the domain, range, asymptotes, and behavior. Okay, so we got lots of stuff to do. This is going to be a growing function because we're multiplying by 3 every time. But this number is kind of confusing, the 1/3 out in front. That just tells you where you're like kind of starting from, right? So the fact that this number is not a number that's greater than 1 doesn't make him a decay function. We're still multiplying by 3 every time. It's just we're starting with a really low number to begin with, okay? So what I'm going to do is I am going to, let's make, a table of values. I'm going to go x and y. Let's start with 0, and then we'll go 1, 2, 3, etc., right? Okay, so if I plug 0 in for x, 3 to the 0 power, this part is going to become 1. Anything to the 0 power is 1. Then I take 1 times 1/3, and that's just 1/3. So at 0, I'm up at 1/3, and I'm going to put that dot there. 1/3. Okay, then I'm going to plug 1 in. So 3 to the first power. What's up?
I'm looking for Amy.
She's across the hall in my room. So 3 to the first power is 3, and 1/3 of 3 is 1. So 1 is at 1, and right here, okay? Then if I plug 2 in, 3 squared is 9, and 1/3 of 9 is 3. So 2 is up here at 3, and there's that point, okay? 3, if I plug 3 in, 3 cubed is 27, and 1/3 times 27 is 9. So 2, 4, 6, 8, 9 is right here. Okay, and I'm going to stop there because I'm going to go off the graph. If we plug in numbers on the left side of 0, he's just going to go like this. He's going to go down, down, down. This is an exponential growth function because he's going uphill, and our horizontal asymptote is here at 0. Y equals 0. So let's fill in some stuff. We need domain, we need range, we need the asymptote. I'm going to say the HA because he's a horizontal asymptote, and then the end behavior. So I'll say end. Okay, so as far as domain goes, left and right, this function is going to go to the left forever. He's going to go to the right forever. So domain is going to be all reals. The range is up and down. He's going to go up forever, but he's not going to go down forever because he never crosses that asymptote. So the y values are going to be greater than, not equal to 0 because he doesn't touch that dotted line. Your horizontal asymptote is at y equals 0. Now, there is a correlation between these two. Whatever your HA is the number that your range will always be, okay? And then as far as end behavior goes, it's like as x goes to infinity, y is going to something. As x goes to negative infinity, y is going to something, okay? As x goes to infinity, that's a fancy way of saying as he's going to the right. As he's going to the right side, he is going up forever and ever and ever, so y is going to infinity. Now, this is tricky. As he goes to the left, he's not going down forever and ever and ever. He's approaching this value of 0 all the way across, so the y value is going to 0. Normally, positive and negative infinity is what we put in those blanks, but since there's a horizontal asymptote, he's going to approach that value, so he's going to level off at 0, okay? So, domain, range, asymptote, and behavior, there's what you need. Okay, so I would start on 6 and 8 by possibly making a table. You can plug this into your calculator if you want to. Like 1/5 is 0.2 if you want to do that. So take it to the 0 power, take it to the first power, take it to the second power, that type of thing. And you will see what he will look like. Okay, so make your table of values and then fill in your domain, range, all that good stuff. Okay, all right. This next one is talking about the transformations. If we start with 2 to the x power, list the transformations that take that to this function. And then they want us to graph, and then they want us to do domain and range. So domain, range. All right, let's do number 9. So if we start with 2 to the x power, the thing that I notice is that this negative is doing something and this +5 is doing something. 2 to the x power is the parent function, so I don't have to worry about him at all. But I need to talk about what this negative is doing and what that 5 is doing. So the negative is going to flip him over the x-axis. It's going to like flip him down, right? So instead of him doing this, he's going to do this. Okay, we'll get to that here in a second. And then this +5 is going to move him up 5, okay? Now, that is a little bit different than, like, let's look at this one, 11. Okay, this guy is the same position as where the 5 was, so this is going to move him up and down, but this guy is going to move him to the left and to the right, okay? And just keep in mind that minus means right and plus means left. So pay attention to where the plus is, where the plus or minus is located. Is it down below or is it up in the exponent? Because those are going to mean two different things, okay? So bumping back over to here, we're going up 5 and over the x-axis. Okay, so this function, 2 to the x power, every exponential function is going to cross here at 1 except for this guy because we had a vertical stretch or a vertical compression. So that's why this guy didn't cross here at 1 because now he's down at 1/3 instead. That's where we're starting from, okay? So if you're wondering why that was the case, that's why. But 2 to the x power, he normally goes like this, right? Actually, I should do this. 2 to the first power is 2. 2 to the second power is up here at 4. So this is what he's going to look like. 2 to the x power. Normally it does that, okay? If we flip him down, all those points are going to be, flipped down. So he's going to look like this. But then I'm going to take and I'm going to move him up 5. Okay, so I'm going to take my pink and this dot right here, if I shift him up 5, 1, 2, 3, 4, 5, he's right here. If I take this dot and shift him up 5, 1, 2, 3, 4, 5, right here. My horizontal asymptote was originally at 0, and if I shift that up 5, right? There is where he will be located. So this is what the pink one is finally what he will end up looking like. Okay, he's flipped down and he's up 5. So the pink one, the blue one was the original, the green one was after I flipped him, and then up 5 will be the pink one. Okay, so the pink one is the final. All right, so, domain and range. Domain, left and right. He's always going to be all reals for an exponential function. Range, he will not go up forever, but he will go down forever. Again, I'm looking at this pink one, okay? He will go down forever, so y is less than, and this dotted line where he has to be lower than is at 5, so less than 5. That's your range value, okay? So that is how that works. All right, go fill in 10 and 11, and then let's talk through some of these on 7.2 section. These are all going to be similar. Let's do like 2 of these together. We'll do, I don't know, let's do like number 12, and we'll do number like 17, because that one has a fraction in it. I guess we could do number 13. Let's do 12 and 13. I don't care. All right, here we go. When we're doing this, we have our 2 bases. Our bases are 4 and our bases are 8. Okay, so 4 and 8, I want to convert those to be the same number. So I always look at the bigger one and say, can I make him into the smaller one? Like, can I change 8 to be like 4 squared? Well, the problem with that is 4 squared is 16. It's not 8. So what I'm going to have to do is I can't just write 8 in terms of 4. That means I'm going to have to switch the 4 also, okay, and make something smaller than 4, like 2. 4 can be written as 2 squared, right? So I'm just going to take 2 squared, like this guy is going to get erased, and I'm going to plop him in as 2 squared. But then I still have the x plus 1 there, okay, so he has to stay. 8 can be written as 2 to the 3rd power. Okay, so now I have my bases that are the same, okay? So I'm going to take 8, and I'm going to erase him, and instead I'm going to put 2 to the 3rd power, because that's what 8 is. And I have 2x plus 3, okay? Then I have to take and I have to distribute this guy through. So he is 2 to the 2x plus 2 power, because I've distributed him through. And then this guy is 2 to the, if I distribute my 3 through, that will be like 6x plus 9, okay? And now I can do this. Cross those off. So I've got 2 with the sound effects, right? You have to make the sound effects at the same time. Okay, get it right. All right, there's that. I have those equal to each other, and then I'm going to subtract the 2x, so I get him over here, and then I'm going to subtract the 9. This is not going to be nice. Did I do that all right? Yeah. Okay. It's just going to be not nice. 2 minus 9 is negative 7, and then 6x minus 2x is 4x. And if I divide by 4, you can leave them as negative 7 over 4 if you want to. So I'll take this answer, or 7 over 4 is 1.75 is what that guy is. So either way, I don't care, whichever. But that is number 12. So you have to try to make your bases be the same. Hey, the really nice thing on 15, check him out. Guess what? His bases are already the same. That's super nice. Then 13. We've got 8 and 16, and 8 and 16. 8, let's see, if I try to write those as the same base. 16 is not the same thing as like 8 squared. That's not true, right? 8 squared is 64, so I got to think of something smaller. Like I know 16 is 4 squared, but I can't write 8 as a base of 4, so this one's kind of tricky. Let's go to 2. Let's say, okay, let's write 8 as, we know that 8 is 2 to the 3rd power. Okay, so let's get rid of 8, and we're going to write him as 2 to the 3rd power. Then I've got x minus 2, okay? Then 1 over 16, if I take 2 to the 4th power, like 2 times 2 times 2 times 2, that will give me 16, but I want 1 over 16. So I make him the negative 4th power, and that will give me 1 over 16. Okay, I'm going to distribute my 3 through. So this is 2 to the 3x minus 6 equals 2 to the negative 4th power. Okay, and then I'm going to cross off my 2's. So I've got 3x minus 6 equals negative 4. This is not going to come out nice either. If I add the 6 over, 3x equals 2, and I divide by 3, and x is 2/3. Okay, there is that. So the other ones are going to be similar to that. 17 should be the only other one that you have a negative exponent, just because 1/9 is the only other fraction that you have. So there's 12 and 13, but 14, 15, 16, 17, those are all going to be nice same thing, okay? Let's do number 18, last one. And then you do up through 19 for homework. They are asking us to use this compound interest formula, okay? So remember that A is the after amount, P is the principal, so this is like the starting amount, R is your rate, N is the number of times you're compounding, and then T is the time, okay, if you need to write that in. And if you need to pause to write that in, go for it. But, all right, Shelly deposits $2,300. That is going to be your P. I'm just going to label these guys. 2.4% is your rate. And don't worry about the fact that it says annual rate. Every rate that they're going to give you is an annual rate, but you're going to compound not annually, usually. So this one's compounded monthly. So don't worry about the annual. Your interest rate is set up to be like, this is just saying your yearly interest rate is 2.4%. That's what the annual means. But annual does not mean your N is 1. Monthly is going to tell you what your N is. N is 12 for monthly, okay? 2.4% for our rate means that we have to move the decimal 2 places. So 0.024 is what our rate is going to be. And then our time is 8 years, okay? So let's plop stuff in and let's figure out what our after amount is. Okay, so we're taking 2,300. I'm just using this formula to plop stuff in. Times 1 plus the rate is 0.024 over N, which is 12, to the 12 times 8 power. Okay, all right, 0.024 times divided by 12. I'm going to do this part first. That is 0.024. And you can type this in all at one shot if you trust your calculator and you trust the way that you typed it in. So this is 0.002. And if I add that to 1, that's going to be 1.002. Okay? So I'm going to make this a little bit easier on myself. If I rewrite the formula, I have 2,300 times 1.002, and 12 times 8, I think is 96. 96. So now I have a little bit easier. I've simplified this, and I've simplified this, and now I have a little bit easier of a formula. So 1.002 to the 96th power. And then I'm going to take that times 2,300. And I get 2786.31. That's what he is. Okay? So that's the amount of money. Now, that seems like a reasonable amount for that to grow. 23 to 27. This next one, 19, is asking you for compounding quarterly versus compounding daily. So you have to do 2 different ones and kind of compare the 2. Okay? So use the rest of your time in class to do those, and there is that.